All right, if you've got a Java final exam coming up, you are in the right place. We're going to cut right through all the noise and focus on the 17 most important theory questions that pop up again and again, helping you study smarter, not harder. You know that feeling, right? Staring at a huge syllabus, not enough time. The stress of just figuring out what to focus on can be totally overwhelming. But what if you could pinpoint your revision on the questions that give you the biggest bang for your buck? Well, that's exactly what we're about to do. And here's the payoff. The source material we're digging into today shows that by just mastering these 17 questions, you can pretty much lock in 30 to 35 marks on your theory paper. That is a massive chunk of your grade secured just by studying smart. Okay, so here's our game plan. To make this crystal clear, we've broken it all down into 6 key sections. We'll kick things off with the absolute basics, then move through object-oriented stuff, handling errors, building user interfaces, networking, and we'll finish up with databases. It's a roadmap that mirrors your syllabus, so it should be super easy to follow along. First up, Section 1, Java's core building blocks. Think of these as the absolute foundation. Seriously, everything else is built on top of this. If you don't have these down, the rest gets a whole lot tougher. So let's make sure you've got them locked in. Let's start by getting 3 crucial acronyms straight in our heads: JDK, JRE, and JVM. Just remember it like this. The JDK is the whole toolkit you use to develop code. The JRE is what you need just to run a Java program. And the JVM, the Java Virtual Machine, that's the engine that actually executes the code. They're a team, but they each have a very specific job. Next up are some other key basics that are pretty much guaranteed marks. You'll probably get asked about Java's features, so remember words like object-oriented and platform-independent. You also got to know the basic program structure, a class with a main method inside. And finally, be ready to explain how decision-making works using an if-else or a switch statement. Nailing these is such an easy win. Okay, on to Section 2, where we start building on that foundation with some core object-oriented ideas. This is where you'll really start to see the power of Java and how it lets you reuse code. Inheritance. The big idea here is all about efficiency. It's about not repeating yourself. Instead of writing the same code over and over, you create a main parent class, and then child classes can just extend it and inherit all its features. It's a fundamental concept. You absolutely have to know it. And here are 2 related concepts you've got to nail down. The super keyword, that's your way of reaching up from a child class to grab something from its parent. And an interface, though, is different. Think of it like a contract or a blueprint. It doesn't have any actual code, it just forces other classes to include certain methods, which guarantees they all follow the same rules. All right, Section 3, handling errors and tasks. Let's be real, a program that just crashes is pretty useless, right? That's why examiners absolutely love to test you on how to build strong, robust code that can handle problems and do more than one thing at once. So, what's an exception? The best way to think about it is like having a plan B for your code. Your program tries to do something that might go wrong, and if it does, it catches the error and deals with it nicely instead of just, boom, crashing. This is a must-know for any serious developer. Now, if exception handling is your safety net, then multi-threading is your turbo button. It's the magic that lets a program download a big file, update a progress bar, and still respond to your mouse clicks, all at the same time. It's all about doing multiple things at once. Next up, Section 4. This is where things get visual. So far, everything's been kind of happening behind the scenes. Now we're talking about how Java builds graphical user interfaces, or GUIs, the stuff people can actually see and interact with. For this part, the main thing to know is the AWT, or Abstract Window Toolkit. It's Java's original box of tools for creating windows, buttons, labels, and text fields. But having the parts is only half the battle. The other half is the event listener. It just sits there and waits for the user to do something, like click a button, and then it triggers the right piece of code to run. Time for Section 5, connecting to the web. I mean, in today's world, what app doesn't connect to the internet? This is a huge deal. This section is all about how your Java programs can talk to other computers over a network, a skill every modern developer needs. You really just need to get your head around 2 main ideas here. First, sockets. Think of them like the 2 telephones on either end of a phone call, connecting a client and a server. That's how they talk. Second is the INET address class. That one's way simpler. It's basically the phone book. It helps you find the IP address or the name of the computer you're trying to call. And here we are, the final piece of the puzzle, Section 6, Talking to Databases. Come on, most programs need to save and retrieve data somewhere, and in Java, we do that using something called JDBC. JDBC, honestly, the easiest way to think about it is as the universal translator. It's the bridge that lets your Java code speak the same language as almost any database out there, whether it's MySQL, Oracle, whatever. It's the standard. Now, this right here, this 5-step process, is a classic exam question. It's one of those things you should just memorize for easy marks. First, you load the specific driver for your database. Then, you connect to it. Third, you create a statement to run. Fourth, you execute your query. And finally, and this is super important, you always close the connection when you're done. And here's a little pro tip to make your answer really stand out. A regular statement works, sure, but a pre-statement is way better. It's faster because it's pre-compiled, but even more important, it protects your database from something called SQL injection, which is a really common and dangerous cyber attack. And there it is, straight from the source guide we analyzed. This isn't just us guessing what might be on the exam. This is a strategic plan. Focusing your energy on these 17 questions is, without a doubt, the most efficient path to securing a huge chunk of your final grade. At the end of the day, having the knowledge is one thing, but you've got to use it. We've given you the roadmap to the most valuable topics for your exam. The only question left is, where are you going to start? So pick a section, dive in, and turn this plan into exam success. Good luck, you've got this.